Hello everyone. In this lecture, I'm going to introduce the concept of toppling. To understand it clearly, I would like to consider this case in which here there is a rough horizontal surface on which a block of mass m, mass of the block I am taking it as m, and let me assume this height is h, height of the block is h, and this breadth of this block I am taking it as b, and height h is the height of this block. Now, if we assume that this surface has some friction also, I'm applying a force F on one of its top edges like this. Before applying this force, if you look at the free body diagram of this block, what are the forces acting on this block? Gravitational force mg will act vertically downward direction, and normal reaction will act vertically upward direction. Now, when you apply a force F along the horizontal direction like this, then what happens? Before applying the force, the line of action of gravitational force and normal reaction, both of them will pass through the center of mass. When you apply a force F, then what happens? The frictional force comes into picture, and whose direction is in this direction, leftwards. If I assume that the body is not moving, then the condition for translatory motion is resultant of all the forces along the horizontal direction is 0, and resultant of all the torques about the center of mass I am taking, this is also should be 0. This is the condition for translatory motion, this is the condition for rotatory motion. By using this condition for translatory motion, what I can write, along the vertical direction, upward force should be equal to downward force. Along the horizontal direction, right side force is applied force, and left side force is the frictional force, which is F. If the body is not moving, this is the condition. Applied force should be equal to the frictional force, because of which the resultant force along the horizontal direction is 0. Now I am coming back for this torque equation. I am writing down the torque equation about the center of mass. If I assume that the body is at rest, then what happens? The line of action of normal reaction and the line of action of mg, if they pass through the center of mass, contribution to the torque will be 0. Contribution to the torque will be 0. That means the torque should be contributed by the applied force and the frictional force only. But if you look at the sense of rotation due to applied force, due to this force, if you fix this point, about this point, due to this applied force, the body has a tendency to rotate in this sense, in this right side sense. And if you look at the torque due to this also has a tendency to rotate the body in this sense. Let me call this as a clockwise sense with respect to me. Okay, so clockwise sense. Both of them are producing torque in clockwise sense only. When there is no counterbalancing torque acting on the body, then what happens? The body should rotate, or the body should topple. But the thing I am assuming here is that the resultant torque is 0, that is the body is at rest. That means here something is wrong with my assumption. What is my assumption? Of course, gravitational force, whatever it may be the situation, always the line of action of gravitational force should pass through the center of mass only. So only possibility is that the normal reaction in this situation cannot pass through the center of mass. I am assuming that it has shifted through to the right through some distance x. This diagram I am one more time I am drawing over here such that things could be somewhat clear. So the same block I am taking on this rough horizontal surface, under the influence of this external force F, gravitational force mg is always, it should pass through the center of mass. This is the direction of frictional force. Now, as I told you, in this case, if I assume the normal reaction is passing through the center of mass, there is a resultant torque acting about the center of mass, because of which body cannot be in equilibrium. That means the resultant torque is not 0. To make this torque 0, what I am assuming is, I am assuming that the normal reaction has shifted to the right direction through a distance small x. In this case, the normal reaction, the line of action of normal reaction is like this. I am assuming it such that the resultant torque may become 0. I am checking whether it is possible or not. Okay, so now again I am writing about the center of mass, torque equation about the center of mass. So just now I told you the applied force, due to applied force, body has a tendency to rotate about the center of mass. Due to the frictional force also, body has a tendency to rotate in this sense, that is clockwise sense with respect to me. And then what is about this normal reaction? Due to this normal reaction, if you look at this, the force, the line of action of force is like this, normal reaction forces. So because of which, due to this normal reaction, the body has a tendency to rotate in counterclockwise sense. That means if I assume that a normal reaction has shifted to the right direction through a small distance x, then what's happening? This normal reaction is able to produce a counterclockwise, that is counterclockwise torque about the center of mass C. And the line of action of gravitational force is passing through the center of mass. It cannot produce any torque about the center of mass. So because of which, now I can write down the torque equation as, first I am writing down the clockwise torques, the forces which is producing torque in clockwise sense. Clockwise means in this sense. So force, the perpendicular distance between the line of action of force and the axis of rotation. If you take this, total height is h. Distance from center of mass to this topward point will be h by 2. Because of which, F into h by 2 plus, due to this, small f into h by 2. This is the total torque which is causing the body to rotate in clockwise sense. That is equal to what you can write here, just now I wrote it here, F is equal to small f. So in the place of small f, if you take capital F, F plus F is 2F. Altogether you will be getting F into H is the total torque which is causing the body to rotate in clockwise. Next I am going to write down anti-clock or counterclockwise. Anti-clockwise, torque in anti-clockwise sense. So for that purpose, what I can do, torque due to gravitational force is 0. Only thing which is producing counterclockwise torque is normal reaction. Therefore, torque due to normal reaction is given by normal reaction force into perpendicular distance between the point of rotation and the line of action of force, that I am assuming it as x. So when body is in equilibrium, what should happen? This clockwise torque should be balanced by the counterclockwise torque, because of which I can write down as n into x should be equal to F into h. Through which I can write down the expression for x as x is equal to what you can write, F into h divided by n. What is n here? N is nothing but gravitational force mg. Therefore, the distance through which the normal reaction is shifted is given by x is equal to F into h divided by mg. So through this, what we can conclude, it is not much that always normal reaction should pass through the center of mass. When body is extended body, what is happening? When an external force acts on the body, the normal reaction is shifting in the direction of applied force such that the normal reaction is producing required counterclockwise torque. Okay, next one more thing that I would like to tell you here is, if you keep on increasing the magnitude of force, then what happens? Normal reaction will keep on shifting to the right. Am I right? After reaching, what is the maximum distance up to which it can reach? It can reach up to its edge only. So when it reaches its edge, then what happens? The value of x will become b divided by 2, where b is the breadth of this, what you call it as block. So up to this extent only normal reaction can shift. So beyond which, what happens? Normal reaction cannot shift, because of which what happens, you know, the body starts to lift up like this. The body starts to lift up like this. This is the scenario. So when if the applied force, magnitude of applied force, if you keep on increasing, the value of x will keep on increasing. After reaching the value of x, which is b by 2, that is to this edge, then what happens? Normal reaction is passing through what you call it as this edge, and the frictional force is to the left direction and the applied force is to the right direction. Then what's happening? At this instant, the body, this edge is getting lifted. This edge is leaving the surface and the body is tipping about this point. This concept we call it as toppling. Toppling means about one point. What is happening? The body is tipping, that is the body is rolling, the body is rotating. This concept we call it as the concept of toppling. So when the normal reaction force keeps on shifting, and when it reaches to this rightmost point, that is the this rightmost edge, then what's happening? The body is tipping about this edge. This concept we call it as the toppling. So in that context, the value of x will be how much? B by 2. Therefore, through this, what you can write? B divided by 2 is equal to what you can write? F into h divided by mg. Here I would like to make one observation. Therefore, the force needed to topple the object is given by how much? Mg into B divided by 2 into h. So here I would like to explain you one point, very important observation. The magnitude of force needed to topple the body, that is to rotate the body, is depending on what? Its weight and on breadth of the object and the height at which you are applying the force. Am I right? So here, if the base length is more, the body is more stable, that is the body is more resistant to the rotation. If the base length is less, that is, for example, here I am taking it. If you take an object of larger height and lesser breadth, then what happens? Even for a smaller force, what is happening? The body has more tendency to rotate than translate. So if you take a body which is in circular form, for example, if you take a disc like this, disc-like object, then what's happening? When you apply a force F, so if you compare these two, what is the size or the what length of the object is in contact with the surface? In this situation, if you compare these two, what's happening? In the case of circle, the length of the object which is in contact with the ground is very less when compared with block. Am I right? Because of which a body of circular aperture or a body of which is in circular form, when you apply a force, it has more tendency to topple, because the length of the body which is in contact with the surface is very less in the case of this circular body. So because of which a body which is in circular form, that is whether it is a cylinder or a sphere or a disc, what's happening? When you apply a force, so the body has maximum tendency to topple. That toppling of this circular body, we call it as rolling. What is that? Rolling. So rolling is nothing but toppling. That means when the base length of the object is very less, then what happens? Even for a smaller force, the body may or may not translate depending on the value of frictional force acting on the body. But body has larger tendency to topple. That toppling of this circular shaped body, we call it as rolling.